Hello and welcome to section 8.3 covering geometric sequences. As you can remember, in the last class we talked about arithmetic sequences, and arithmetic sequences, as a reminder, are sequences that will create a pattern of repeated addition. That number that we are adding to get from term to term to term is called the common difference. Remember, that's notated with a lowercase d. Today we're going to talk about geometric sequences. Geometric sequence is another subcategory of infinite sequences, and a geometric sequence is a sequence that has repeated multiplication. So to get from one term to the next, you are multiplying by the same number. That number is called the common ratio. Call it the common ratio because to calculate it, if it is not given, we need two consecutive terms and we divide the second one divided by the first one. So we're going to do the same type of things that we have been doing in the last couple chapters, sections. The first section we were asked to write the first four terms, and in that section, because we didn't know what pattern we would have, we had to have the general term, the a sub n expression or the nth term expression for our sequence, and then we plugged in the number that we needed to find the value of. In the second section, we were asked to find the first six terms, but for an arithmetic sequence, we were given the common difference and we just had to do repeated addition. Today we're asked to find the first five terms of a geometric sequence. Geometric means multiplication. So in this example, we're given a sub 1 equals 12. We want to find through the fifth term, so we're going to find a sub 2, a sub 3, a sub 4, and a sub 5. Because this sequence, they're telling us it's geometric, we know that there's a number that we have to multiply by to get our new terms. So if our first term is 12, then our second term will be calculated by taking that term and multiplying it by 1/2. Well, 1/2 of 12 equals 6. So if our second term is 6, our third term will take the previous term of 6 and again multiply it by 1/2, which equals 3. And we will continue that pattern of taking the previous term and multiplying it by the common ratio of 1/2. Now 3 times 1/2, remember 3 is over 1, can be made a fraction, and when we multiply fractions, we multiply the numerators and multiply the denominators. So we get 3 over 2. So our fifth term takes our previous term of 3 over 2, and again, repeated multiplication by the common ratio of 1/2. This is going to give me 3/4. So I have a sequence of 12, 6, 3, 3 over 2, and 3/4. And this pattern will continue by multiplying by 1/2. That is the definition of a geometric sequence. We need no formula to find consecutive terms. All we need is a term and what that common ratio is going to be. Okay? Now, just like arithmetic sequences, there are formulas that will allow us to find the a sub n, which again, remember that means our general term. Another name for that would be the nth term formula. An a sub n formula will also allow us to find the value of any given term. Just like in the a sub n formula for arithmetic sequences, n is the number of term you're finding the value of. So if it's the nth term, n stays n. If it's the 10th term, n becomes 10. A sub 1 is the value of the first term, and again, r is your common ratio, which remember is a sub 2 divided by a sub 1. So this is our first a sub n formula, or our first formula for geometric sequences. A sub n represents the general term of the nth term. It can also be used to find the value of any term in a geometric sequence. So here I'm given, I wouldn't even need to tell you it's geometric because I'm given an r. We know an r means common ratio, and that is associated to a geometric sequence. But in this sequence, our first term has a value of 5 and our common ratio is -3. The directions say use the formula for the general term of a geometric sequence to find a sub 7. A sub 7 means we need the a sub n formula. So our first term times our common ratio raised to the n minus 1 power. Well, this formula says I need to know n. Well, n is right here. It is 7. So I'm looking for a sub 7. A sub 1 is 5. I'm going to multiply that by the common ratio of negative 3 raised to the n minus 1 power. And we know n is already 7. So if we simplify this, we get 5 times negative 3 to the 6th power. Notice that my exponential portion of this, since the base was negative, I did use parentheses. Remember how important that is in a calculator. If you don't put the parentheses around this base of negative 3 before you raise it to the exponent, it's likely to give you the wrong sign of your answer. Okay. Order of operations says I have to do exponents before I multiply. Negative 3 to the 6th power is 729, and 729 times 5 is going to give us a seventh term of 3,645. Okay, again, I could use recursion, 5 times negative 3, and term 2 times negative 3, terms 3 times negative 3, and so on and so forth, but they specifically tell me to use the formula. Okay. Here we have a sequence of 3, 12, 48, and 192. Again, I wouldn't need to tell you that it's geometric because 12 divided by 3 equals 4. 48 divided by 12 also equals 4. 192 divided by 48, that also equals 4. Which means this is a geometric sequence whose common ratio has a value of 4. The directions say write a formula for the general term of this geometric sequence. So they want an nth term formula. That means we're looking for the nth term of this sequence. That is the sequence that we could use to find the value of any term. So n is going to stay n. Our first term is 3 times our common ratio of 4 raised to the n minus 1 power. Now when we did this and found the nth term in arithmetic sequences, there was something to simplify. Order of operations here, I have multiplication and I have an exponent. Order of operations said I would have to do that exponent first, and since my exponent contains a variable, there's nothing I can simplify there. So this is my nth term, or my general term for the sequence 3, 12, 48, 192. Then I want to use this formula for a sub 7. So that means my n becomes 7. So 3 times 4 to the 7 minus 1 power means 3 times 4 to the 6th power. 4 to the 6th power is 4,096. So 4,096 times 3 gives me a seventh term of 12,288. I hope you are calculating these. Remember, you can pause the video and calculate it to make sure that you're coming up with the right answers and you know how to do it yourself, not just waiting for me to show you. Okay. As you probably suspected, for geometric sequences, we also have a sum formula. This formula will allow us to find the sum of the first n terms of a geometric sequence. Okay. Just like arithmetic sequences, in order to use this formula, we have to know it's geometric, and our sum has to start at the first term. If our sum does not start at the first term, even if we know it's arithmetic or geometric, we can't use formulas. We'll have to go back to what we learned in the first section, find the individual terms that go into our sum, and then add them up. In this formula, we do have an n. Just like in the arithmetic formula, the n is no longer the nth term or a specific term. It is the number of terms you're finding the sum of. So if I'm finding the sum of the first 10 terms, n would be 10. Again, a sub 1 is the value of the first term, and r is the common ratio. Again, a sub 2 divided by a sub 1, sometimes that will be given. Sometimes we will have to calculate that on our own. So find the sum. Sum means S sub n of the first 9 terms of the geometric sequence 2, negative 6, 18, and negative 54. Well, here's my sum formula. This formula tells me I need to know n, a sub 1, and r. Well, n, I'm finding the sum of the first 9 terms. A sub 1 is given as 2. R isn't given, but I can calculate it. Remember, a sub 2 divided by a sub 1. So negative 6 divided by 2 gives me a common ratio value of negative 3. Once I have those 3 values, I can simply plug them into the formula and follow the order of operations. This formula is a little bit more complicated, and you will need to do things step by step. If you try to plug it into your calculator all at one time, I can almost guarantee you without proper parentheses, it's not going to give you the right answer. So do your work step by step. Show your work step by step so that if you make a mistake, I can find it. So S sub n equals A sub 1, that is 2, times the value of 1 minus, sorry, I put an R there, 1 minus our R value. Our R value is negative, so again, I'm going to put that in parentheses. And we're going to raise that to the n power, which is 9. All of that will be divided by 1 minus negative 3. Okay, so order of operations says do grouping symbols first. So 1 minus the value of negative 3 to the 9th power. If you plug that into your calculator, negative 3 to the 9th power is going to give us a negative 19683. So a negative 19,683. On the bottom, 1 minus negative 3 is 4. So inside here, when I'm subtracting a negative, I can add the opposite. That's going to give me 2 times 19,684. That's going to be divided by 4. 2 times 19,684 is 39,368. And then I can divide that by 4. And the sum of the first 9 terms of the sequence 2, negative 6, 18, negative 54 is 9,842. Again, see how I showed all of my work step by step. I didn't try to plug it all into my calculator at one time. I followed my order of operations, did one thing at a time so that I can get to the right answer. Okay. One last example. This one is a sum in summation notation. Remember, this symbol means find the sum. So we know if it's geometric and my lower limit is 1, I can find the sum using an S sub n formula. Okay. And again, in the S sub n formula, I need n, I need A sub 1, and I need R. Well, n, I can calculate by my lower and upper limits, so I'm going from term 1 to term 8, so I'm finding the sum of the first 8 terms. A sub 1, this is my general term formula, so I can plug in 1 in there. 3 to the first power is 3. 3 times 2 gives me a first term of 6. Now, in the formula, I need an R. R is A sub 2 divided by A sub 1. Well, I have A sub 1 as 6. Although A sub 2 will not go into my formula, I do have to calculate it so I can find my R. So 2 times 3 squared, that's going to give me 2 times 9, which means my second term is 18. So my R value is 18 divided by 6, which equals 3. Now I have my 3 values that I need to go into my formula, so I plug it in, follow the order of operations. So I'm finding the sum of the first 8 terms of this sequence. My first term is 6. Multiply that by 1 minus 3 to the 8th power, and all of that will divide by 1 minus 3. So again, one step at a time. 6 is going to multiply by 1 minus the value of 3 to the 8th. 3 to the 8th power is 6,561. And on the bottom, 1 minus 3 is negative 2. So 1 minus 6,561 is going to give us negative 6,560. Again, I'm dividing that by negative 2. 6 times negative 6,560 is negative 39,360. Divide that by negative 2. A negative divided by a negative is a positive. So the sum of my first 8 terms is 19,680. If you have any questions, let me know.